In this video we're going to work with compositions of functions. So compositions of functions are a little different than sum, difference, product, and quotient. If we have two functions f and g, the composition of f with g is denoted as f of g. This is not f times g. Keep in mind, this is an open circle right there between the f and the g. Very, very important. Some people start writing with a closed circle and they start thinking it's multiplication. They're like, no, it's fine, I know what it is. And then all of a sudden we have multiplication at one time and we have f of g at another time, and people multiply it and they get all upset. So make sure you remember that it's f of g. That's not a multiplication sign. And it would look like this, f of g of x. We're plugging in g of x for all the x's in our f function. Now that sounds crazy. Let's do an example. In this first example, we have f of x equals x squared plus 4 and g of x equals 2x. And I'm going to be doing f of g. So I'm going to plug g in for f. Now let's see how that's going to look. I'm going to take this 2x here and I'm going to plug it in to the x in my f of x function. Okay, so I'm going to have f of, we'll use some colors here, g of x equals, parentheses, the 2x goes in place of that x there, squared plus 4. So my g of x, that 2x there, was plugged in right here. Now I'm going to continue simplifying while I can distribute this squared to both the 2 and the x. It's multiplication in there, so I can distribute the 2. If it was 2 plus x, we'd have to FOIL. That's another problem for another time. And then we have 2 squared is 4, x squared plus 4, and I am done. Now let's try g of f. So I have g of f of x. What I'm going to do here is plug my x squared plus 4 into the x in the g of x function. So we're kind of switching it up here. Well, I have 2, and then I'm going to replace that x with x squared plus 4. Now I'm going to distribute my 2, and I get 2x squared plus 8, and there's my answer.